All right, let's dive right in. In the next few minutes, we are going to unpack two of the most critical roles in all of tech, SRE and DevOps. These are the folks who build and safeguard our entire digital world. We're going to break down exactly what they do and what it takes to become one.
I mean, think about it. Every single time you click a button, stream a show, or make a purchase online, you're relying on these unbelievably complex systems to work perfectly. But how does that actually happen, 24/7, without a hitch? Well, that is the high-stakes world we're about to explore.
So let's kick things off with SRE, or Site Reliability Engineering. Now, this is not your classic IT job where you're just reacting to problems as they pop up. No, SRE completely flips the script. It treats operations as a software problem. So instead of manually fixing a server, an SRE writes code to automate the whole system. It's a massive shift in thinking.
So where does DevOps fit into all this? Well, you can think of SRE as a very specific, hands-on way to do DevOps. If DevOps is the philosophy, the what, breaking down those walls between developers and operations, then SRE is the how. It's DevOps with this laser focus on reliability baked right in from the very beginning.
And you can really see that hybrid nature when you look at the skill set. You have to be part software engineer and part systems architect. You've got to be able to code, you need to know the cloud like the back of your hand, and you have to be absolutely obsessed with automation. But just as important, you need the mindset of a first responder. You have to be calm, you have to be analytical when the pressure's on. It's this really unique mix that makes these roles so incredibly valuable.
Okay, so we've got the skills down. But what does an SRE or a DevOps engineer actually do all day? Let's get practical and break down the day-to-day work.
This table is a fantastic snapshot. A typical day is really a blend of offense and defense. Your offense is the proactive stuff, building automated deployment pipelines, defining your entire cloud infrastructure using code, and setting up all the monitoring so you can see everything. But the second an alert goes off, you switch to defense, and you become the leader of the incident response team. Now, to juggle all those responsibilities, you're going to need the right toolkit. We're going to zero in on 3 pillars of modern operations that you absolutely, positively have to master: CI/CD, infrastructure as code, and observability.
First up, CI/CD. This here shows the automated trip that code takes from a developer's laptop to a live user. The second that code is committed, a pipeline just kicks into gear. It builds the code, it runs tests, it scans for security holes, and then it deploys. But look at that last step, monitor. That right there is the critical feedback loop that makes the whole process safer and faster every single time.
And these are the tools that make that pipeline hum. You've got platforms like Jenkins to actually run the automation. You've got tools like Docker to package everything up neatly into containers. And then you have the undisputed king, Kubernetes, to orchestrate it all, which is just a fancy way of saying it manages thousands of those containers at a massive scale. Mastering these is non-negotiable.
All right, next is infrastructure as code, or IaC. This basically means you treat your servers, your networks, your databases just like software. It's all defined in code and tracked in version control. The two heavyweights here are Terraform and CloudFormation. And here's the big decision you have to make. Terraform is cloud agnostic. It'll work with AWS, Azure, GCP, you name it. CloudFormation, on the other hand, is AWS's own native solution. So your choice really comes down to whether you're all in on one cloud provider or if you need that multi-cloud flexibility.
But IaC isn't just about the tools. It's about the principles behind them. Take idempotency. It sounds complicated, but it's a simple idea. No matter how many times you run your code, you get the exact same result. It's predictable. And GitOps takes that a step further, making your code repository the one and only source of truth for what your infrastructure should look like. This makes everything predictable, repeatable, and super easy to audit.
Our third pillar is observability. If your system is just a black box, these are the tools that let you see what's happening inside. Think of yourself as a detective on a case. Metrics are the system's vital signs. Hey, CPU is at 90%. Logs are the witness statements. The database connection failed at exactly 3:15 a.m. And traces, well, traces are like the security camera footage, letting you follow a single user's request from start to finish to pinpoint exactly where things went sideways.
Okay, so we've talked a lot about building these super resilient systems. But let's be real, no system is perfect. Things will break. Failures are just inevitable. So let's talk about how SREs master the high-pressure art of incident response.
So just picture it. It's 3 in the morning.
Your pager goes off. It's screaming at you. The main application is down, and every single second of downtime is costing the company money and burning through user trust. Do you panic? Nope. A trained SRE has a calm, structured, battle-tested plan ready to go.
And this right here is that plan. It all starts with detection. Then you triage. How bad is this really? Then containment. You have to stop the bleeding. Resolve. Fix the root cause. Recover. Get the service back up. And finally, maybe the most important step for the long haul, the postmortem. That's where you dig in, figure out what went wrong, and make sure it can never, ever happen again.
Look, you can't improve what you don't measure. SREs are obsessed with tracking metrics like mean time to detect and mean time to resolve. But check out that last point, no blame postmortems. This is a huge cultural cornerstone. The goal is never, ever to find a person to blame. The goal is to understand how the system allowed the failure to happen so you can make the whole thing more resilient.
And that brings us to a really crucial point. Being a great SRE is about so much more than just knowing the tools. It's about a fundamental shift in your mindset. From being a technician who just fixes things, to being a strategist who builds systems that are automated and can even heal themselves.
This table really breaks down that strategic mindset perfectly. Error budgets, for instance, they give you a data-driven way to balance pushing out new features with focusing on stability. Toil reduction is just this constant, ongoing war against boring, repetitive manual work. But my personal favorite is chaos engineering. This is where you literally act like a movie villain and intentionally break parts of your own system, in a controlled way, of course, just to prove that it's as tough as you think it is.
And honestly, this quote from our source material just says it all. The goal isn't to just be a firefighter who's always reacting to problems. The goal is to be an architect, someone who builds the intelligent, resilient, and scalable infrastructure that's going to power our future.
Look, this role is demanding. There's no question about it. It's incredibly complex. But as we've seen, it's about so much more than just keeping the lights on. It's about being an architect, a strategist, and a guardian for the digital services that we all depend on every single day. So the real question isn't just if you're ready, but what are you going to build?